All right, so in assignment number 6, we're going to be simplifying exponential expressions that involve quotients, that are basically fractions. So let's go ahead and get started and see how we do with this. All right, so this first one, we have n to the 6th over n to the 4th. Let's first think about what this means. N to the 6th means that in the numerator we have 6 n's. So we have 6 n's on top and we have 4 n's on the bottom. These are factors, and so as factors, they can cancel each other out. And what we have left is 2 n's left on top once everything gets canceled out. So n to the 6th over n to the 4th is simply n squared. Now, there's an easy way to get the n squared, and that is when you have like bases and you're dividing them, you subtract the exponents. In our last lesson, we had like bases like n to the 5th times n to the 3rd. So we had like bases and we were multiplying like bases, and we learned that in that case we add the exponents, because here we'd have 5 n's times 3 more n's would be a total of 8 n's. So this is very similar to what we just finished in assignment number 5, only we're dividing the like bases, and so when we do that, we just simply subtract the exponents. So let's go on to number 2. This is a little bit more involved here. It involves a lot of the other exponential rules that we already talked about. So what we're going to start with is we're going to take everything here to the 3rd power, everything in the numerator. So that includes taking 2 to the 3rd power. 2 to the 3rd power means 2 times 2 times 2. Well, that's 8. And then a to the 3rd power is simply a to the 3rd. And then b to the 3rd to the 3rd. So this goes back to the power rule, where we're taking a power to a power. And so when we take a power to a power, we multiply those. That's b to the 9th. And again, the reason why it's b to the 9th is because we have b to the 3rd to the 3rd. In other words, we have that 3 times. And so here I have 3 b's, 3 more b's, 3 more b's. That's a total of 9 b's that I'm multiplying together. All of this is over the denominator, which is 4a to the 5th and b to the 2nd. So let's simplify our regular numbers first. If I have 8 over 4, that's the same thing as just 2 over 1. So that simplifies to 2 on top. Now I could put a 1 in the denominator, but I don't need to have that. If I have a to the 3rd, then over a to the 5th, I'm going to subtract those. A to the 3rd over a to the 5th is a to the negative 2nd power, because 3 minus 5 is negative 2. And so that's a to the negative 2nd. And then if I have b to the 9th over b to the 2nd, that's b to the 7th power. And so all of this is over 1, but then I have a negative exponent, and I want to move that to make it a positive exponent, and I make a negative exponent positive by moving it to the bottom. So I would have 2 and then b to the 7th on top over a to the 2nd on the bottom. Another way of thinking about this is 8 over 4 is 2, but then a to the 3rd and a to the 5th, I would have 5 a's on the bottom and 3 a's on the top. These 3 a's would wipe out 3 of these a's, and I would have 2 a's left over on the bottom. Same thing with the b's. I have 9 b's on top, 2 of them on the bottom. These 2 b's would wipe out 2 of these b's, and I have 7 b's left over. And you can see I get the same thing regardless of how I think about it. So it's 2b to the 7th over a to the 2nd. Let's take a look at another example. So this time we have this whole thing in parentheses to the 2nd power. And so that means, just like when I take an entire product to the 2nd power, this too applies to every expression in the parentheses. And so what I'm going to do here first is I'm going to take everything to the 2nd power, including the 3. 3 to the 2nd power is 9. X to the 5th to the 2nd, that's a power to a power. That's x to the 10th. And then y to the 2nd to the 2nd, that's a power to a power. So again, I multiply, that's y to the 4th. And so there isn't anything else that I can simplify. My final answer is just going to be 9x to the 10th over y to the 4th. Got one more problem to look at here, and there's 2 ways that I can do this problem. One way is that I could simplify the fraction first and then square everything, or I could square everything and then simplify it. Let's do that way first. I'm going to take everything here and square it. So for example, 6 squared is 36. This is all on top, at least at the beginning here. And then x to the 5th squared is x to the 10th. Then I have y to the 3rd squared is y to the 6th. And again, I'm multiplying because it's a power to a power. Then in the denominator, 2 squared is 4. X squared squared, if it's a power to a power, I multiply. That's x to the 4th. So then I'm going to simplify these things. 36 over 4 is 9. X to the 10th over x to the 4th. I'm going to subtract those exponents. That's x to the 6th. And then y to the 6th. So this simplifies to 9x to the 6th, y to the 6th. Now, another way to do the same problem would be to simplify the fraction first. Like, for example, I have 6 over 2. Well, that's 3. I have x to the 5th over x to the 2nd. If I subtract 5 minus 2, that's x to the 3rd. And then I have the y to the 3rd. And I could take that whole thing and square it. But if I do that, I'm going to have to square everything. 3 squared is 9. X to the 3rd squared is x to the 6th. And y to the 3rd squared is y to the 6th. And you can see I get the same thing both ways. This is what our assignment is going to look like for tonight. And we will work on this and go over questions tomorrow in class.